My name is Hon Chian. In this video, I will explain about my engineering technology design project assignment 4. So the first part that I will explain in this video is the design task 1, which requires us to develop a traffic light controller for vertical traffic light and horizontal traffic light by implementing decoder. So let me run the program first. So when the input value of V0 and V1 are both equal to 0, it will turn on the red light. If the input value of V0 is equal to 1, it will turn on the green light. If the input value of V0 has changed back to 0 and the input value of V1 is given to 1, it will turn on the amber light. If the input value of both V0 and V1 are equal to 1, it will turn on both green light and pedestrian green light. And this is done by implementing the decoder, and I have put my decoder into the subsystem. So let me explain more details about my subsystem. So this is two input value, which is V0 and V1, and 4 different cases of traffic lights. So in the first case, which is to turn on the red light, is when the input value of V0 and V1 are both equal to 0. So in this case, this input value need to pass through this inverter to make it become 1 and connect to the AND gate. And the AND gate is also connected to a constant value of 1, so that the output value will become 1. So in this case, it will show the display of 1 and it will turn on this red light. So for the second case, which is when which is to turn on the green light, when the input value of V0 is equal to 1 and the input value of V1 is equal to 0. So in this case, because this input value is already equal to 1, so we don't need to pass the value through the inverter. We can just directly connect it with the AND gate. While for the second input, we need to connect it to the inverter to make it become 1, and it's also connected to the constant value of 1. So for the third case, which is to turn on the amber light, we need the input value of V0 to become 0 and the input value of V1 to become 1. So this input value will pass through this inverter and connect to the AND gate, and this one will directly connect to the AND gate and also connect it with the constant value, so that it will all become 1 and produce an output value of 1. So for the fourth case, which is to turn on the pedestrian green lights, is that when the input value of both 0 and V0 and V1 are equal to 1, so we can just directly connect it with the AND gate with a constant value, so that it will produce an output of 1 to turn on the pedestrian green light. So there is an OR gate used here. This is because when the input value of V0 and V1 are both equal to 1, we will turn on the pedestrian green light and green light. So to achieve this, we need to use the OR gate to ensure that when it's in the fourth case, which is when both of these are equal to 1, it will turn on the green light, and when this output value is equal to 1, it will also turn on the green light. So this OR gate will ensure that if even which case is equal to 1 of both these two situations, it will turn on the green light. So the working principle of the horizontal traffic light is work in the same way. Like so when we give the input value of H0 to become 1, it will turn on the green light, and it will turn on both the pedestrian green light and green light, and lastly it will turn on the amber light. And it's also using the decoder and connected in the same way. And this is all for my design task 1. So next I will talk about my design task 2, which is traffic controller. So for this task, there is 3 inputs, which is train button, pedestrian button, and the car button. So the train button has the highest priority. When this train button has been turned on, it will perform its action, even though this pedestrian button and car button is also turned on. So this train button will perform an action, which is flash action, which will toggle the red and amber lights with a frequency of 10 Hz. And so the next one is the pedestrian button, which has the second high priority. So when it is activated, but the train button is not activated, it will perform its action, which is a pedestrian green action, and in the pedestrian green action will turn on the pedestrian green light. And the car has the lowest priority, and it can only perform its action when the train button and pedestrian button is not activated. So for the car button, it will turn on the green light by producing a green output. So so let me run the program to see how does it looks like. Okay, so when this train button has been turned on, so it will flashing. Even though this pedestrian button has been turned on, it will not run its action. So this pedestrian button will only perform its action when I have turned off this train button, and it will turn on the pedestrian green light. And this car button will only perform its action when I turn off this pedestrian button. So this is done by implementing a state machine. So let me explain more details about my state machine. So I have put 3 stats into this state machine. So for the first one is when the train button is pressed. So I have labeled this stat. So I've named this stat as train button. So it will produce an output which is flash equal to 1, while these two outputs is equal to 0, and it will change its stat when uh, when when the trend is not equal to 1. So that if the trend button is activated, it will not change its state, and it will only change its state when the trend is turned off and it is not equal to 1. So like if we activate the protection button, so if it detects that the trend button is not equal to 1, then it will change to protection button state. And it also runs for the car, but the car is only performs when both the trend button and protection button are not equal to 1. So I set the highest priority for the protection button to 1 and the second high priority to the car button to 2. So the trend button can switch to the protection button when the trend button is not equal to 1 and the protection button is equal to 1. So in this case, the protection green it will produce a protection green output which is equal to 1. And it can also switch back to trend button if the trend button has been turned on. And this protection button can also be switched to car button state when the car button has been turned on, which will produce an output value of 1. And this will only be occur when the protection button has been turned off, which means that it is not equal to 1. So in the car button state, it will turn on the green light while the other two light will be switched off. So I have also set the highest priority for this protection button to the to switch to trend button first if trend is equal to 1, and the second high priority to the car button. So for the car button, it also works in the same way. It will switch to 1 when it detects that the trend button has been turned on when this trend input is equal to 1, and it will also turn on the protection button when the protection is equal to 1. And it can only occur in the case that the trend button is not turned on. So this is roughly how my state machine looks like. So there is also a requirement for us to toggle the red and amber with 10 hertz frequency. So to achieve this, I actually use the formula T equals to 1 over F to get a 0.1 second, so that when I turn on the system and the trend button has been activated, it will toggle the red and amber light with 10 hertz frequency. And I have also also integrated with this one is actually just now what I have explained for my design task one, and this is actually that I have get from my workshop exercise 4, and I have put them all together, and that is all for my design task 2. So the last part that I will explain in this video is design task 3, which is to develop a production memory function. And so this task is actually requires us to develop a memory function state machine, which is used to store the memory of the production button. This is because when the trend button has been turned on, it will perform the trend button actions even though we have pressed this production button. So this memory can help us to store the input value of this production. So it will perform its action after we have turned off this trend button. So this is the state machine that I have for design task 3, which consists of 3 inputs, which are production inputs, which is come from the production button, and it will give an input value of 1 when I have pressed it 1 time. And trend inputs, which is come from this toggle switch, is used to detect whether the switch has been turned on or turned off. And the last input is action serve, which is the memory from the traffic controller state machine. And this is actually a new output has been added for the traffic controller state machine. And there's only one output from this state machine, which is production output. So let me go more details about this state machine. So for the normal state, which is when the production button has not been pressed, it will produce an output of 0, so nothing will be happen. If the production button has been pressed, it will produce an input value of 1. So it will transfer from normal state to trigger state and produce an output value of 1 and go back to normal state. So this output 1 will go to the pass to the production inputs of traffic controller state machine. So in this state machine, it will transfer all these states to the memory state, even though it is under which state, it will just pass to the memory state. And this memory state is actually give the inputs, give the output value of action served to 1. So as we can see, that's because we have set this one to 1, so it can transfer from any state just to memory state when it has been pressed. So it can transfer from, so the condition is the production is equal to 1. So after action serve has give an output value of 1, so it will pass it to the pass back to the memory function state machine. So in this memory function state machine, it will store the action serve with a value of 1. So in this case, it will wait until the trend button has been turned off. So when the trend button has been turned off, it will not be equal to 1. So when the button has been pressed and saved as a memory, and the trend button has been turned off, it will transfer from normal state to production button state and produce an output value of 2. And because we are using the button, so when we press it one time, it will go back to 0. So when it go back to 0, it will go back to the normal state. And I have created a small wait for 15 seconds, which is a request for the question. So it will go back to the normal state. And this prediction output equal to 2 will be passed to the traffic controller state machine. And and it will go to the prediction button state when uh, this prediction is equal to 2, as we have stored the memory, and in the condition that the trend is not equal to 1. And this car button will also go to the pedestrian button state when we press it. So it will turn on the pedestrian green light. It will produce an output of pedestrian green equals to 1 to turn on both the green and pedestrian green lights. And it will reset the action serve to equals to 0, so that it will not continuously go to this state and go back, just like a loop. So this one is this action serve is used to close it. And this is most of the. So let me run the program. So as we can see that because the car button has been turned on, so it will turn on the green light. And if we press this train button, it will automatically go turn on the green and pedestrian green light. And if we turn on the train button, so it will just toggle this red and amber light. So after we have toggled these two lights, so we can press this button and it will store the memory. So if we close it, it will automatically count for 15 seconds and it will close after 15 seconds. And this is all from my assignment 4. Thank you.